ice. While it's doing that, the water valve is also energized and filling this thing up with water. Okay, so as ice is ejecting, the water valve is resupplying that container with ice. So we have some connectors here. We're going to go ahead and just pull this assembly out. Got a 1/4 inch nut back here. Then I'm going to take this out. That screw's super long. I still can't get it out. How long that screw was. So that will drop this whole reservoir down, and so we have some quick disconnects. So we're going to go ahead and release the connections here. I am going to need a pair of needle nose pliers. Pause it for a second. In order to get this assembly out, we have some wires that are caught in here. I'm going to go ahead and try to pull them loose. But we also have these two hoses here. One hose, this big one here, this hose here, is to catch the water coming off the evaporator and direct it back into this bin. So that's all this is. It goes here on this trowel here and returns it back into the bin. And we'll go ahead and take that one apart just to get that out of the way. So this is, the evaporator runs into this, like this, so the water running off the evaporator, anything that doesn't freeze will hit this tray and run down this tube and go back into the reservoir where the pump can pump it back up. And I'll show you where it pumps to and how it pumps back over the evaporator. But this is to catch it from splashing into the ice bucket. So our controls are here, and up inside here is the computer board. So you have to actually take the top off to get to that. So we're going to do that in a minute. So let me discuss some things down here and turn around and discuss the things in the back, and then we'll take it down off the table here so we can look at the top of it. So this is our condenser here. This is our water valve. It's a little hard to see here, but there's something called a hot gas valve. That hot gas valve is a solenoid that controls the flow of the refrigerant. Normally when a refrigerator runs, the compressor pumps into the condenser. Condenser goes through a cap tube up to the evaporator, and it comes back to the compressor. We want to release the ice. The hot gas valve down here will stop the refrigerant from going to the condenser and change its direction to go straight up to the evaporator. So the compressor is pumping high pressure refrigerant into the evaporator to warm it up and cause the ice to slide off. Commercial machines do the same process. They have hot gas valves, and when they're ready to release ice, they pump high pressure refrigerant into the evaporator so that ice will come loose. So this is what we can see from the front. Here's the back. We got our compressor. We got a little drip tray here. This is our refrigerant line running across the back, and we'll go ahead and take that off just so you can see it. So this will be our suction line and our liquid line, our capillary tube, which is running from the condenser. So this is just accessing our refrigerant flow through the unit. I'm going to put this on YouTube. I saw one of these covers laying over there where you guys are working that goes on one of my ice machines. It's not on my ice machine, it's laying on the table. So we need to reinstall that. I'll put that on YouTube so everybody knows. My students didn't put anything back. Blame all of you.
That was from last semester. That wasn't us.
You were here last semester.
No, the semester before that.
Can you say the name of the person you think did it?
It's got to be Ann Sucker.
What are you talking about? This is my first week of refrigeration. I haven't touched ice maker yet.
No, but we can show them the floor.
What floor?
The burn mark that you left the other day.
That wasn't me.
On my vinyl floor.
This is the first time I'm doing this.
So, The wiring coming from the computer board here is running down the back wall, which is feeding our compressor, our water valve, our condenser fan, and our hot gas valve. Now we added another component here, which isn't always on all of our ice machines. And surprisingly, it came with the ice machine because the older ones, you have to buy it as a kit. Now the service manual, if you watch the first video, the last section on that service manual has the kit for installing this, what we call condensate pump. So normally this hose will be a straight hose, and if you can see, it's cut out down here. So the customer is supposed to have a drain on the floor that this hose could run down into a gravity-fed floor drain. But let's say someone lives in an apartment or a condo on multiple floors and they don't have a drain on their floor. So this drain directs water into this reservoir, and this reservoir has a float switch in there. So as it fills up with water, it hits that switch will initiate the motor and tell the motor to pump out. And you could run it into the drain where the washing machine goes. You could run it into under the sink. And what does this hose look like? A dishwasher drain hose. And basically this will go on to the condensate pump right here. And you can run this hose to your garbage disposal, but let's say you already have a disposal and a dishwasher, and that hose is going there. Well, then you can't connect this here. But if you have a dual sink, the other sink, they sell just a pipe that has a fitting for a dishwasher. You don't have to have a garbage disposal to hook up a dishwasher. You can have the pipe with that fitting on it, and you can connect this to it so it would drain in the house sink. So if you had this in the kitchen under the counter in your kitchen, but you have no place to drain it, you can connect it to the second sink if the garbage disposal is being used for the dishwasher. Don't tie it in to the dishwasher drain, because what could happen is that dishwasher pumping water into the disposal, if the disposal's got food in it and stuff, it causes a backup, and it'll cause that dirty water to run down here into this reservoir here. Now, it still won't get to your ice, but you don't want that dirty water from your garbage disposal and your dishwasher pumping into another machine. You want to keep it clean. So that you want to have a separate pipe. So this can also go into where like a washing machine standpipe would go, where the washing machine would drain. And if you want, you could drill a hole right through the wall if it's got an outside wall, and you can run it right outside the house. So that's that. Now the condensate pump here, I don't know if I have the right size for that. Let me just see real quick here. No, next one down. We'll go ahead and pull this condensate pump out. The older ones, it must be metric. I don't think I have the right size fit for that. We'll find it. No, I can't get to it at all. But we take these nuts off, we can pull this out. I don't have the right size tool here. So you just disconnect this. And one thing I want you to notice, which is important, is there's a plug right here plugged into this condensate pump, but yet we have a plug going out here that goes to the wall. This plug is connected to the condensate pump, then the machine itself, this is the wiring harness for the machine, is plugged into the pump. And that's how this pump will shut this machine off if it's not draining. So in other words, if this thing is filled up with water and for some reason it doesn't pump the water out, the pump's bad, or the float switch doesn't activate that pump, the float switch hopefully has a secondary safety in there that will shut the whole ice machine off and say stop making ice because this is full and it can't handle any more water. Now problem is, if that happens, the ice machine stops producing ice. You got 50 pounds of ice in here, what's gonna happen? I shut the machine off, that's gonna melt. So if that customer doesn't realize that that ice machine is off and this stuff is melting, this will still overflow and get water on the floor. All right, so this hole is, we'll look at it when I take the parts off, is just right in the bottom of the ice bin. So the recirculation has a pipe that goes to it, but it's not sealed to the bottom of the ice storage area. It is open so that when that ice melts, it runs down the same drain. So this here is there's no electrical or anything. What happens, refrigerant lines run up here, and sometimes especially in warm, humid areas. Sometimes people put these outside in like their pool area, and they have an ice machine out there where the pool is when they have a party and everything. So sometimes condensation will build up and drip. So they got this pan here to catch this, and then just the heat of the condenser air and the compressor back here will gradually cause that to evaporate. So that's the components. You can't really see it. In front of the compressor, you'll find a condenser fan motor in there as well. So can you give me a hand a second, and we'll set this on the ground, just let that run. We'll just put this right on the ground there. Pull the cord. Set it down. So you have to adjust the camera so we can see it. All right. So we have some screws back here.
Stand up or catch one.
So this here is how you get to the computer controls. If this is in a kitchen cabinet, you have to pull this out. This will lift up here, but we have a screw in here. We might have one hidden behind this hinge. You notice we got extra holes here? What do you think those holes are for?
Switch the door on.
Reverse the opening. So this door opens this way. We can move the hinges to this side and open it up that way. We're going to have to take this off. This is a torque screw. That's the wrong size torque. This is the right one. Taking it off completely, I'm just going to loosen one, take off the top one, and just let it hang down. So now I got two more screws here, Phillips. Oh, that's torque. Well, it should be the smaller torque. Of course, they're not all the same size. This is my first time opening this new machine. This machine's brand new. They didn't even screw that one straight. Look at that, from the factory, it's crooked. I'm gonna send it back. Tell them they sent me one with a crooked screw.
Tag them in the video.
So we get them out, and then we're gonna go ahead and we're just gonna lift this up. And this allows us to get all the computer controls and everything in here. So this is our filter housing assembly here, and inside here is a computer. I'm not gonna show you that till after we go through the rest of the components here. Okay, so this is how we get into the electrical, and I'm just gonna lay this on top of this cart here for now. So this is the evaporator. You can see it a little bit more clearly now. This right here is like a spreader, so that the pump pumps from down here, runs up through the back here, and runs through here, and then this spreads it out to a couple little holes like a sprinkler system, and then the water hits the evaporator and runs down. The biggest thing I see wrong with these, besides the water valve or the circulation pump failing, is, can you see these lines here?
Mm-hmm.
These lines here is because they sort of like weld the refrigerant lines that are underneath here to this plate. So those lines are actually where it is welded to the plate. But it's almost like it rusts. And over a period of time, I've seen right here on these two end points, I've seen it rust and freon leak out.
Wow.
And we have to replace the evaporator. But the problem is this particular unit is, I don't know if it's 600 or 134A. Let me double check. I can't see it. I need some better eyesight.
Half a glass wear glasses, so I don't know.
I can't even see the, can you see that? Can you see the model and serial plate? Does it say what refrigerant? I can't see it. What does it say right there? 134A?
Yeah.
Okay, so this is still a 134A unit. They haven't gone to 600A. So 134A unit, just like a refrigerator, this evaporator runs at about 0 PSI. Okay, But if we start losing Freon, this evaporator goes into a vacuum. Then what happens is it would suck water from your evaporator into your refrigerant system. And that means if you gotta change the evaporator, you might end up having to change a dryer filter and a compressor on this unit. So you wanna make sure that this don't leak. So how do we check that for leak is when the compressor's not running, we get the refrigerant out, and we put nitrogen to 100 PSI when it's not running, and then we can soap test this and see if it bubbles with the 100 PSI refrigerant. So I'm going ahead and disconnect this recirculation hose here. This is that diffuser. I'll try to remove it without breaking it. So you can see the little holes here. And what this does is that when the water comes in, these little holes spread it out so that the whole evaporator gets a clear flow. Okay? So now that this hose is disconnected, we're going to pass it down here and get it past this evaporator. I'm going to have to loosen the evaporator. Should have a drill, make it faster, but
We don't use drills in this class.
I don't let you guys use drills. You guys destroy all my machines. You strip out all the screws, and then the screw
Oh, man, that
screw is
was-
supposed to be this small. It's about as big as a lug nut on a car.
That's a class before us.
Yeah, the same one that burned the floor, I guess.
Yeah, man, that guy's terrible. They burn everything.
So give me a second. We gotta get this wire off. Alright, so now that I've moved the evaporator loose, I got this hose here, and this is the one that's running from the circulation pump up to that diffuser. Did you guys get any needle nose pliers?
Yeah,
It's right up on the,
it's on the cart.
Oh, it's on the cart. So we got two clips here. See if I can pop these clips out. I end up having to break those clips if they don't come loose. Well, let's see here. I'll get the clips. Alright, that one came out. So, this is our reservoir assembly that fills with water. That little gray hose I showed you earlier fills this whole reservoir, and it's actually even deeper there where the pumps are. We'll tear that apart. There's a small little hole right here at the top. Can you see that hole there? That hole is right here. So when it's filling up with water, if the water goes higher than that hole, it just runs down into the bin, and there's a drain right here in the bottom and just runs out to that condensate pump. So we have two pumps, recirculation pump and a drain pump. Go ahead and we'll take the drain pump off. This is to drain out the water. With one screw, you take off a bracket, then you just rotate it and drop it down. This has a little impeller. This piece can actually come out of the motor, and in the book they tell you if this piece is up in here and you're just changing the motor, that's okay if it comes apart in the video. So this here is the drain pump. Now, so it's in the bottom of that reservoir, but notice how it runs here and down and just runs right into the bucket as well. So why did they put this? Why did they go all the way up? Because if the water in the bin goes too high and this hose came straight out, it would just gravity drain out. So this is opposite of a trap like in your sink. The trap in your sink keeps gases from the sewer to come in. Well, this here has got to go higher than the water in here. If it doesn't, it's like that. Now they have a small hole in the top of that hose. Does anybody know why that's there?
the air just so that it can move.
No, to prevent it from creating a siphon, because it could start pumping out the water like it wants to put fresh water. And if it starts filling at the same time as the pump started pumping and the pump shuts off, it could create a siphon. And while it's filling, it's sucking the water out because of a siphon. So that little hole is actually there as a purpose to break the siphon so that the machine will be allowed to fill. Okay? So this is the drain pump, and you'll have to come here to get to this plug to get it out. I'm not going to go ahead and take it off. So you still have to drop this, even though you can drop the motor. If you can't get this piece out of here while it's up in the machine, because remember, you're underneath this evaporator trying to work, you might have to drop this whole assembly down to take this out. Now this here on the top is our recirculation pump, and it has two little clips here, one here and one here, and the plastic part comes up and your recirculation motor is out. So did that get caught on the film? So when you pull this out, it comes right with your recirculation pump. And sometimes this pump just builds up with algae. It's not that the pump is always bad. So what you do want to do is take this hose off and check to make sure it's clear and there's no obstruction. And if it's still not circulating water, then we have to replace this pump. So once this happens, then we just slide this motor out. There's some locking tabs here. Right here, there's some locking tabs. There's some locking tabs on this side. So you basically just have to get that tab past the plastic. Little flat screwdriver.
Which one?
We don't have one here available, so don't worry about it. Just, I popped it off that side. Then I pop it off this other side, then the pump will just pull right out from the top. I'm just gonna snap it back in place. It's really not that easy, but I'm gonna snap it back in place, okay? So the drain pump goes underneath, like this, and the circulation pump on the top, okay? So now you can see our evaporator a little better. I'm gonna tilt it back just a little bit, and there's an accumulator down here. So as the evaporator is forming ice, and the water now is flowing over the ice, not the evaporator, we're not as absorbing as much heat from this evaporator. So what the accumulator does is it traps any liquid refrigerant and prevents that liquid refrigerant from coming back into the compressor and damaging the compressor. Okay, so here is our electricals. And I'm gonna need someone to hold this while I take these screws out. We're gonna go ahead and open this up. Someone come over here and hold it for me. You won't be in the video. You shy?
I want to go and find it.
Go on the other side.
You're already famous. From the hall.
My voice is famous. Why don't you go up there? Like one of them documents.
I think there's a screw there, and I have to get this filter housing cover off just to get to that one last screw. So in order to get that, I have to take this filter housing assembly off. And it's the shorter, smaller torque bit. This is the small one. It's even smaller than that one. Oh, this is. Screw and tilt it a little bit this way. So now that I took this cover off, I want to show you guys this filter housing assembly here, that you can see these two gray lines that are running here. So instead of the water valve going right to this compartment, that water valve is running up to the filter housing assembly and then running into the recirculation reservoir. So the filter is in between that here. So here we have a little LED lights to light up the bin. When a customer opens the door, there is a reed switch in here. A reed switch works off of magnetism. When you close the door, there's a magnet inside the door, and that runs up against a reed switch, which is right about here, and turns the light off. When you open the door and the magnet's not there, it turns it on. So if you look here, where do you think that magnet is?
In the middle?
That little indentation right here.
Yeah.
Look. That's the magnet. So it lines up somewhere in, I think it's right here in the corner in the video. The reed switch is here, but we have to get to it through the controls. So we're going to go ahead and drop this ice maker down. And the controls, I don't think the screws are all loose. Let's see. That one's loose.
That's loose.
That's
That one's
loose.
loose.
There was one down here that had to get that filter housing off. I think that's a screw. There's one here. This one's still holding. I want to catch them before they fall in the bin. I know I'm going to run down the drain. So, look what we got in here. Now, I think that ground off. You can set that down. I'll edit this video a little bit to reduce the time to take all these screws out. Thank you. So here we have the transformer. This transformer steps down to multiple voltages. In the first video I talked about the voltages. One of them is for the cutter grid assembly. Remember I said the cutter grid's not 120 volts, it's low voltage. The LED lights have a different voltage, and then we also have to feed voltage to the control board. Most computer boards don't run directly off 120. They have to drop the voltage so the little resistors and all that other crap work. So this is our main board assembly. Power supply coming in. This is our power supply area and a transformer on this board. These little black boxes are relays. One is for the compressor. One is for the water valve. One is for the drain pump. One's for the recirculation pump. And another one is for the condenser fan motor. So that's all controlled by this here. And then on the other side, you see this plug and this plug here. One of them is the cutter grid, and the other one, actually this is the cutter grid, and this one here is the bin level sensor. Now what we don't see is our evaporator thermistor. Well, there they are. Well, 3 of them came out just before. That 4th one's still in here. So if I tilt this back some, this is the underside. This is actually the evaporator tubing here. Even though this is called the evaporator, the freon's running through tubing underneath. Right here in this area of the suction line is the evaporator thermistor. This is what's telling the unit the temperature of the evaporator. So when it goes to redrop the ice, remember that the hot gas valve down there is pumping the hot refrigerant up here. This is sensing the hot refrigerant. When it reaches a specific temperature, it knows that it's warm enough and the slab should already be off of the evaporator, and that's how it knows to stop the ice harvest cycle and go back to ice production. Okay? Now this unit has a built-in cleaning feature, and whenever you turn these ice machines on for the first time, they will run through a 5 to 10 minute cleaning cycle, and it'll throw fresh water in there and clean itself out before it'll go into ice production. So if you're a technician, you unplugged it, plugged it back in, wanted to see it make ice, and you see water flowing but no ice production, it's not because there's something wrong. You might be in the cleaning cycle. Now in the manual, you can press some buttons here and go into diagnostics. I'm not going to go through that today, but these are all the components here. Now if you look at this piece right here, inside, it's hard to see, there's a switch there. It's the same as a refrigerator light switch. And what that is if the filter is not in here, it won't let the ice maker run. It's not because we say, oh, we want them to buy a filter so it'll run. The hoses are connected to the inside and the back there, and if the filter's not there, water's just gonna shoot out of here. It's not gonna go into our recirc reservoir and make ice. So you guys got any questions? Yes.
Why certain machines don't have cutter grids like this one?
Because let's say like the U-line, for example, or the Scotsman ice machine, the mold that makes the ice already makes individual ice cubes. U-line is a big rectangular slab. It has little square holes, and the water flows over it and freezes in each hole. So when it goes to drop ice, a lot of them have like a little finger with a motor in the middle that pushes the whole slab, and when it falls into the bucket, they're supposed to break it into individual pieces.
Got it.
Sometimes you'll see like one whole section with a bunch of small cubes on it, but it makes the squares in the evaporator itself, where this one here makes a big one that has to cut it into smaller cubes.
Oh,
Okay? This here also, by the way, this little black piece right inside here, that's that reed switch for the light when you open and close the door. That's where the magnet, it's way down here. I think it lines up right about here. And that's where the reed switch is. Again, that's in the service manual. And if you watched the first video, I identified all these components in here. What if I had to do a sealed system job? Yes, I want to pull out the condensate pump. I do want to remove this little drip tray, but still you got all these walls that make it very difficult to service. So what they did, I'll put the tool over here. What they did is they have these screws in the back, and that's 5/16, not a quarter. We remove these screws here. Now remember I said these refrigerant lines run here. Now this piece will lift up off the back, and you put like a little 2x4 underneath there. In the video it shows you, but it's better to take the evaporator loose with screws and bring the evaporator over the back, and these lines are just loose here. And so now the evaporator's not there, you got the compressor and condenser and evaporator, you could take this entire cover off and out of the way for service. So if you're doing a sealed system job, unlike a refrigerator where you're right in there trying to get a torch in there and you can't see and you're afraid of burning stuff up, this particular unit, we could take this whole cover off, we can service the sealed system and put this cover back on. But in order to take this off, you have to remove the evaporator from inside. You're not disconnecting the lines, you're just unscrewing it and then lifting it up and over the back of this unit so this whole cover come off. Let's see if we can do that. I just got 2 more screws to take out here. All right, so we're gonna take this cover off. What we did is we removed the controls. They're still connected to the wiring and just laid it down. I removed the filter housing with the hoses. Took this hose out of here. I removed the drain hose that's going to our condensate pump here. I removed this fill hose, which is attached to the sidewall. In the front is the water valve itself, which is also attached to that sidewall. And remember the 2 screws I took off here, there was 2 more in the front at the bottom, so all 4 of them hold it down. So once that out, the one last thing we gotta do is I loosened up all the screws for the evaporator. So the evaporator itself should be able to lift up like this. And we gotta be very careful because we're bending the refrigerant tubing. And that tubing runs through here, as you can see. I get it up and over. Let me get on the other side so I can see what I'm doing.
Yeah, that is.
So this is the evaporator and the refrigerant lines. So if I had to replace this evaporator, I had to do a compressor replacement or something, we want to get this cover off, all this has to come off to get this out of our way. So I want to be careful. I need someone to hold this so I don't let this fall to the ground. There you go. So now this whole cover comes off the ice machine. So I got that, thank you. So now that we got it open for you to see it, we have to be very careful with this line. I don't want to kink this line here. This line can be easily damaged. We have to be careful. If we're changing the evaporator, it will come with all these lines and connect directly to the compressor. So we just disconnect here and reconnect the evaporator. It's not that big a job. Now that it's open like this, it's easier to service. If I had a compressor to replace, take that whole cover off and I can replace that compressor there. So now you can see a little bit bigger view of our condensate pump. This here is our hot gas valve. This is the one that's connected to our refrigerant line. Normally when a compressor is running, the discharge line is pumping Freon into the condenser here, and it normally runs here into the condenser, and well, actually it runs, see if I can find the inlet from right here. It runs here into the condenser, and it has two ways to go. It can go to the top here, or it can run here to our hot gas valve. When the hot gas valve is closed, the refrigerant runs through the condenser, goes through our filter and our capillary tube, and that capillary tube runs here up to the evaporator, and you can see it right here goes into the evaporator and goes into the evaporation here. Then it comes back here to our accumulator, back to our suction line and compressor. When the hot gas valve is energized, the compressor still pumps here into this tube. Some refrigerant will want to flow this way, but want to flow into the condenser, but the hot gas valve being open now causes the Freon to change direction. And then this piece here runs up to the evaporator and pumps directly into the evaporator without a capillary tube. Okay, the only time we use a capillary tube is when we're refrigerating, producing ice. So that will come up here and refrigerant will flow through here normally. When we go to remove ice, the hot gas valve just goes straight up here. The ice slides off and produces ice. So that's about it. Is there any questions about any of these components or anything about the service of it?
No, good.
No?
I think it's the ice that it makes.
The ice is approximately 1/4 inch to about 3/8 of an inch thick. About that big. Okay, they're decent size ice. They're not real big. Remember, this machine only runs for about 20 to 25 minutes on average. Normally it's not timed. You know what I did not see on this particular unit? I did not show you, now that you mentioned that. Is that this particular model does not have the water level sensor.
Oh.
So how does this one know when to drop the ice? Question, anybody got the answer? If it does, I said the water level sensor on the newer models is what tells it to drop the ice. This reservoir here, this reservoir, when it fills up with water, there's a sensor in here that's sensing how much water's coming in. When it's circulating, it freezes, and that water starts to drop as it's turning to ice up top. The water level sensor sees it gets low enough, it knows that turned to ice, and it would stop dropping ice. But this one doesn't have the level sensor. I would see it probably mounted right in this opening here or in that opening there, and it would go down into the water level on our recirculation pump. So how does this one know when to drop the ice? I said the old ones drop the ice by what?
Time.
No, by the suction line evaporator thermistor. The evaporator thermistor has to be somewhere up here.
It's
Is it
on
on the
the
table?
I think with
This is a bin thermistor. And the evaporator thermistor is not connected here. I unclipped it. I just don't know where we set it down. Pause that for a second. Here. This is our evaporator thermistor. That evaporator thermistor clips onto this line right there. So if you can't see it, take your phone or something, take a picture with a camera so you can see where it is. Don't just pull it off and say, man, I don't know where I took it off. I need to put the new one on. Okay, so this here is our connections to our pumps, our recirculation, our drain pump. And then this one connects up to the main board.